Hello, Husker Senior Design Capstone Project teams. My name is Brian Gadel. I am the project lead that will be working with you. I am a manager in the technical operations area for McCain Foods, and I'd like to take you through our capstone design project and go through a little bit about our facilities, about McCain, talk about the plant in Grand Island where you'll be working the project, go through a few of our team resources and members, and then get into the project objectives and why we think this is a pretty awesome project for your team to work on and for you to select as your senior design capstone project. So a little bit about McCain Foods. Our company started back in 1957. Two brothers, Harrison and Wallace McCain, started the company, a small town in Florenceville, New Brunswick, with just over 30 employees, and it has grown substantially. Currently, we're over 23,000 employees strong. We are located in just about every region of the world, have over 50 facilities throughout the world. And when you look at our production capabilities and what we do, our facilities make one of every 4 French fries that are consumed throughout the world. We currently are in other areas besides fries. About 25 years ago, our company also expanded into snacks, appetizers, and other areas of food. And so that sort of brings into the project scope that you'll be working on is at our plant in Grand Island, Nebraska. And it's one of our appetizer plants, and we'll talk more about that in a little bit. But again, McCain Foods, if you haven't heard about it, a very large player in the global food market, and still a family-owned company. So a little bit about our McCain Foods Grand Island plant in Nebraska. It is a large-scale processing plant, over 500 employees working there. We produce about 400,000 pounds of onion rings per day. And when you look at that, that's about 10 truckloads of onions going out of that plant every day to customers across the U.S. and the world. And this is the facility that the project will be impacting and working through. It's a facility we'll be going out to. It's only an hour or so away. So we'll be doing some exploration there and utilizing this facility as our test facility for any of the outcomes of the design project. One of the key pieces, just getting finished up, a $30 million improvement project for the facility. New equipment, major equipment on a couple lines, new production line. So McCain has continued to invest in this facility and to make it world class. But it is also the largest onion ring producing facility in McCain's global network, and the investment has been put there. So pretty neat things happening in Grand Island right now. This is our resource group and the McCain team that will be supporting this design project. Again, myself as the project lead, but our project sponsor is the plant manager, April Garski. And then we've got some really solid key resources that will be assisting us and helping us when we run into items that we need assistance on. Hunter Hickey, the engineering manager, be working a lot with Jeff Luther, the process engineering manager, especially the computer resources and the data teams. And then also we've got an IT resource from McCain that we did not have before, Matt Moldenhauer. So we believe we've got this project resourced well to be able to support and keep it moving as needed. So let's get into the area that the design project is focused on. This is our end cut area at the Grand Island plant. It's where we manually place the onions on this end cutter to cut the root, the stem off, and take the peel off of it. This piece of equipment does have a camera system on it, a vision system, where we can see the onions passing under. So this is the area that we're looking at to come up with some solutions to improve the area and automate the area. So I'm going to run this video so you can see what the employee is doing and how they're placing the onions on. So we'll be working, and the key pieces of this project are to focus on orientation of the onions and then also placement of the onions onto this piece of equipment. And if you can imagine doing that 8 hours a day, which these employees are, they rotate back and forth, but there's someone placing onions on here 24 hours a day by hand with this. So it's a key piece for us to improve and make changes to move us forward. So as we look at the project objectives, I've broken it into two areas, and you definitely, as a project team, will be working together. But I think there's two distinct areas, and you'll have to come together to combine and work together to come up with the finished product. But for the computer science side of the project, taking the camera data, the vision information, and being able to give us and measure onion status in relation to the XY axis, and being able to track it at the different degrees so we can give feedback and understand from a yield perspective where we have issues and how effective the onions are being placed onto that pocket chain. So we're looking to be able to, with our current system, allow you to look at it and determine how we can measure that XY axis. We also have another camera system available for the team to utilize if it requires multiple cameras. We think we'll be able to support that and allow you guys to work through that. And then taking that information and doing a number of things with it. One would be building a dashboard so we have feedback to the operators and to the team on a daily basis on the accuracy of onion placement. And then also being able to take that to provide a warning system when it does get out of control and determine what the best method to do that alarming system would be to the operators on a real-time basis. And then the other side of that is giving camera and taking camera information of onions and seeing if you can deliver alignment or at least camera positioning of an onion to the robot, so the robot could pick the onion and then correct the positioning and put it at a different orientation. So there's a couple of things here we're looking for the team to work on, and taking the information out of the vision system, understanding how to take that and create some programs to support real-time feedback to current operators, but also really to drive the automation side of it, where we can provide feedback to the robot for correct alignment and then tracking measurements and giving feedback to the team on a daily basis. There is one other computer science focus we have for this, is to take our daily onion performance reporting, which is a process that takes anywhere from 2 to 4 hours today for people to pull different data segments together. We want you to take a look at that process and see and come up with a solution to automate it so we can pull data from various systems and have one automated daily report and eliminate the need for someone to take 2 to 4 hours to pull this information together. For the mechanical side of the design project, these are the key objectives we have for the mechanical and the design team. The first one picks up, it's a continuation of what the last team had started on. There's some different items that the team came up with how to pick the onion, and a different tools, end of arm tools. We actually have purchased a mini Delta robot, so it'll allow you to trial end of arm tooling and placement of onions. So that is a key thing that we want to continue and build on, and come up with prototyping for the robotic pick and placement and orientation of the onions onto that pocket conveyor. We'd like to look at the opportunity of how we can do mechanical singulation of onions and orientation, so we could provide that to the robot and simplify the moves the robot would have to take. So we think that's a key piece, and we'd like you guys to work on some options and prototyping for mechanical singulation. And then two other areas we'd like to investigate and look at is there a different onion pocket or an onion cup that holds the onion that would do a better job and automatically rotate and singulate the onion? And we want to talk and have you guys look at some concepts and prototyping for that. And the last one on this, peel improvement. After you cut the root and stem off, we need to take all the peel off the onion. Currently, we're about 85% effective with our current process. We want to get to where we have a process that's 100% effective for peel removal. And so we'd like to see some work on and concept work on different ways to take the peel off. We currently use air and some rollers, but are there better rollers? Are there different ways we could take the peel off that would be more effective, use less energy, different things like that? So these are the key objectives we're looking at from the mechanical team. Again, combining the two groups together to be able to understand the orientation of the onion and give feedback to the robot, as well as the robot working off of the camera system, is going to be key. So there's some individual pieces that each team can work on, but ultimately the final and main solution we're looking for is how we can utilize the vision system and the robot to ensure that we're placing the onions correctly on the XY axis onto this equipment. So after reviewing the objectives, in the end, these are the deliverables we're hoping to get out of the design team and from the design team. We're looking to see a percent straight, so the alignment on the XY axis, a software solution to provide us, again, the way to measure it, and then also how to provide us real-time feedback and reporting through a dashboard. We're looking to see a prototype of how we can pick and place the onions onto that moving conveyor belt and orient them correctly on the XY axis. If we can support that with some manual singulation process, look at different variations for the onion pockets that would potentially help with our alignment and could do it automatically, and then come up with the conceptual peel improvement options and work on those. And the last piece, automating our solution for daily onion performance reporting. So these are deliverables we're looking for from your project team. So as a senior design project team, I know your question is going to be, why do we want to select McCain Foods for our project versus others? So here are some reasons that I think are important for you to look at and understand. Currently, from the challenges from the last project, we've actually prepared and have this project team ready to be more successful. We have purchased and have a Delta robot that is going to be available for your team and ready to use. We've got an additional camera system that you'll be able to use and utilize. And then we also have live plant systems. So you'll be connected and hooked into the live plant systems to be able to look at vision systems, understand what's going on with the equipment. We're prepared to connect you to our facility and our plant, and through myself and my project assistants, to make sure you have every piece available to make you successful in your project. The different videos that are running on the sides are projects we've currently or worked on in the past. And I think it's important to realize when you look at the one on the top right, we failed at our first try at what this project is focused on, is orientation alignment on a moving conveyor belt with a robot. And we failed at it. But part of gaining success and moving forward is failing and learning from it and moving forward and trying again. And so we currently, to hit our 2030 vision of being $20 billion in sales, we need to automate systems, make ourselves more productive. And we're currently doing that. We're currently working on multiple projects in automation and with robotics. And we're looking for your team to be part of our robotics world to improve our processes and come up with that next solution. And my question to you, are you going to be that team that helps us achieve and break through and find the next prototype to put on the line and become the next automation project for McCain Foods? So thank you for your time. I look forward to your selections and working with your team for the Senior Design Capstone Project. Thank you.